Hey everyone, welcome back to HackProKP. In today's video, we are diving deep into the network layer of the OSI model and the Internet Protocol stack. By the end of this video, you will understand what the network layer does, how it works from sender to receiver, the roles of routers, key concepts like forwarding, routing, data plane and control plane, and of course how it all works together to move packet across the internet. Let's get started. Section 1 Overview. What is the network layer? The network layer is responsible for transferring data from the source host to the destination host across multiple networks if needed. It does this by encapsulating the data coming from the transport layer like TCP or UDP into what we call as an IP datagram. Section 2 The journey. Sender to routers to the receiver. Sender. At the sender end, the transport layer gives the segment to the network layer. The network layer wraps this segment into an IP datagram, adds important information like IP addresses and passes it to the link layer for transmission. Routers, middle of the journey. Routers along the path doesn't care about the actual data. They look at the headers of each datagram and decide where to send it next, from one port to another, until it reaches its destination. This is where forwarding and routing comes in. More on that in a minute. Receiver. Finally, when the datagram reaches the receiving host, the network layer checks for errors like using checksums, pulls out the payload and passes it to the correct transport layer protocol, whatever they are using, TCP or UDP. Section 3. Key functionalities of the network layer. Now let us talk about what the network layer actually does at a technical level. Let's start with forwarding. Forwarding is local and hardware level. This is about moving the packets within a single router from the input port to the correct output port. Think of it like reaching a junction or interchange on a highway. This is quick, local and mostly done in nanoseconds. Now let's talk about routing. Routing is global and software level. This is about planning the best path from the sender to the receiver, like using Google Maps to find the fastest way across cities. This decision is based on routing algorithm and updates that routers constantly exchange. Section 4. Data plane versus control plane. To manage forwarding and routing, the network layer is split into two logical planes. Data plane. It works locally inside each router. It decides how a datagram should be forwarded based on a forwarding table. Every router has its own data plane that does this job. Control plane. This is the brain of the network. It determines how the paths are built for one router to another. It involves routing protocols and builds or updates the forwarding tables. Section 5. How is the control plane implemented? There are two main approaches here. One is traditional routing algorithms and the other is software-defined networking or SDNs. Now let's talk about traditional routing algorithms. This is implemented within each router. Each router makes its own decision using protocols like OSPF, RIP, BGP, etc. Now let's talk about SDNs. Think of it like remote control routers. SDN controllers, usually in a data center, compute the forwarding paths. These controllers then push the forwarding table to each router remotely. This makes the network more flexible, programmable, and centralized. Let's tie it all together with a real-world analogy. Think of your data like a parcel. The network layer acts like a delivery service. The sender prepares the package from the right address, encapsulation. Routers are delivery hubs that check the address and pass it to the next hop. The receiver opens the package, decapsulation, and gives it to the right person, transport layer. And that's it for today's video on the network layer. We talked about encapsulation, forwarding, routing, data versus control plane, and even SDNs. I will leave a quick single page note covering everything we studied today in the GitHub repo, so make sure to check it out. Links in the description below. If you enjoyed this breakdown, please drop a like and consider subscribing for more deep dives in networking and cybersecurity. Thanks for watching and I will see you in the next one.